Bees are very busy little matchmakers, wingmen in every sense of the word. You see, the bees' side of the whole birds and the bees business is to help plants find mates and reproduce. In their work as pollinators, honeybees are integral to the production of nearly 1/3 of the food that we eat. And these bees, dutifully helping lonely plants have sex, aren't alone, but rather are part of a very complex network of matchmaking creatures, critical for the pollination of natural ecosystems and crops. Plants in many natural ecosystems need help to have sex. Like many of us, they're too busy to find a relationship. They have too much photosynthesis to do, and they can't find the time to evolve feet and walk to a singles bar. Those places are called meat markets for a reason, because plants can't walk. So they need matchmaker pollinators to transport their pollen grains to flowers of the same plant species, and they pay these pollinators with food. Today, around 170,000 plant species receive pollination services from more than 200,000 pollinator species. Pollinators include many species of bees, butterflies, moths, flies, wasps, beetles, even birds and bats, who together help pollinate many species of trees, shrubs, and other flowering plants. In return, flowering plants are an abundant and diverse food source for pollinators. For instance, fossil records suggest bees may have evolved from wasps that gave up hunting after they acquired a taste for nectar. Plant pollinator networks are everywhere. Ecologists record these networks in the field by observing which pollinators visit which plants, or by analyzing the identity of pollen loads on their bodies. Networks registered in these ways contain from 20 to 800 species. These networks show a repeated structure or architecture. Pollinators interact with plants in a very heterogeneous way. Most plants are specialists. They have only one or a few matchmakers. Meanwhile, only a few generalist plants hire a diverse team of matchmakers, getting visits from almost all the pollinators of the network. The same occurs with pollinators. Most are specialists that feed on only a few plant species, while a few pollinators, including the honeybee usually, are generalists, busily feeding from and matchmaking for almost all the plant species in that ecosystem. What's interesting is that specialists and generalists across both plants and pollinators sort themselves out in a particular pattern. Most pollinator networks for which we have data are nested. In a nested network, specialists tend to interact more with generalists than with other specialists. This is because if you're a specialist plant and your only matchmaker also specializes on you as its only food source, you're each more vulnerable to extinction. So, you're better off specializing on a generalist pollinator that has other sources of food to ensure its persistence in bad years. The same goes if you're a specialist pollinator. You're better off in the long run specializing on a generalist plant that gets pollinated by other species in times when you're not around to help. Finally, in addition to nestedness, the networks are usually modular. This means that the species in a network are compartmentalized into modules of plants and animals that interact more with each other than with species in other modules. Think of them like social cliques. A plant or pollinator dying off will affect the species in its module, but those effects will be less severe on the rest of the network. Why is all that important? Because plant-pollinator network structure affects the stability of ecosystems. Heterogeneous distribution, nestedness, and modularity enable networks to better prevent and respond to extinctions. That's critical because nature is never static. Some species may not show up every year. Plants flower at different times. Pollinators mature on varying schedules. Generalist pollinators have to adapt their preferences depending on who's flowering when. So from one flowering season to the next, the participants and patterns of matchmaking can drastically change. With all those variables, you can understand the importance of generalist pollinators like bees to the stability of not only a crop harvest, but the entire network of plants and pollinators we see in nature and rely on for life. Next time you see a bee fly by, remember that it belongs to a complex network of matchmakers, critical to the love lives of plants all around you.